Okay, so we're going to solve more rational equations here. Obviously, they're going to be more complex. And then we're also going to learn to solve absolute value equations, which really we're going to review it, because this should be a review. So again, for rational equations, we've done this already. We find the LCD, we multiply all the terms by the LCD, which the goal is to cancel out the denominator, and then we solve. And once we solve, again, because there's going to be a variable in the denominator, we always want to check for extraneous solutions. So again, we come over to here and we start working this out. So we look at it and we see these denominators and we say, okay, well, what is the least common denominator? Well, you have a factor of 4 and you have x plus 1. So it's going to be 4 times x plus 1. So you're going to multiply everything by that. So when I go to do that, in the first fraction, it's going to eliminate the 4, which is going to leave the 4x plus 3 to be multiplied by the x plus 1. In the second one, the minus 2x, the x plus 1 is going to go away, which is going to mean you have to multiply the minus 2x by 4. And the last one, you're going to multiply the x by all of it. So it's going to be times 4 times x plus 1. So let's start by simplifying that. So I have to FOIL the first set here. It's going to give me 4x squared plus 4x plus 3x, which is plus 7x plus 3. I'm going to multiply the minus 2x and the 4, so that's minus 8x. And then over here, this is going to be 4x, and I'm going to distribute that, so I'm going to get 4x squared plus 4x. And so again, I'm going to combine my like terms over here. 4x squared minus x plus 3 equals 4x squared plus 4x. I have 4x squared on both sides, so that can cancel. And then I'm going to move the variable over to the other side. So I'm going to get 3 equals 4x plus 1x, so it equals 5x. And if I divide both sides by 5, I'm going to get that x equals 3/5. Now the only thing I have to do here is make sure that that's not an extraneous solution. And when I look here, the only thing that x cannot equal would be -1. And so this is a valid solution. It's okay. So that's problem number 1. Now we go to the second problem. So again here, we notice our denominators. We have an x minus 4 and an x minus 4. So as long as I multiply by x minus 4, my denominator should cancel out. Okay, so I'm going to come over to here, and when I multiply the first fraction by x minus 4, it's going to cancel, so x is going to stay by itself. When I multiply the second one, and I multiply by x minus 4, it cancels out again, and it stays 4. And then the last one has no denominator, so it's just going to be 4 times x minus 4. So again here, I have 4 plus, I'm going to distribute this, 4x minus 16, x equals 4x minus 12. I'll subtract 4x from both sides. I'm going to get here, I'm going to get minus 3x equals minus 12. So when I divide both sides by minus 3, I get x equals 4. Now again, I come back to the original problem and I look and see if x equals 4, my denominator is 0. Well, guess what? That can't happen. So this is a no solution, or like that, or no real solution, okay? We keep going here. Let me kind of separate that out. And let's go to this last one. And again, I notice on this one, I have denominators. This one here, x squared minus 4, actually converts to, or factors to, x minus 2, x plus 2. So I know that x minus 2 and x plus 2 is at my actual LCD, so x plus 2. So what I'm going to do is, again, I'm going to take the very first fraction, and when I cancel the x minus 2, I'm going to be left with 3 times x plus 2. When I go to the second one, right, the x plus 2 is going to cancel, and I'm going to be left with 1 times x minus 2. And when I go to the last one, both of the factors are going to cancel, leaving me just with 12. So I need to distribute the 3 here. I need to distribute the 1 here. And 12. So I need to combine my like terms. 4x plus 4 equals 12. I need to move the 4 over to the left by subtracting 4 from both sides, and then I need to divide both by 4, and I get x is 2. And once again, I go back to the original problems and I check denominators. And I realize that x cannot equal 2 because it would make a denominator of 0, which is not allowed. So again, this is another no solution, even though we did all the work. And mathematically, 2 is a solution, but it's extraneous because of the kind of problem. So again, we keep going. Now we have, some additional problems here. Again, notice they start to get more and more complex. Well, again, this is a trinomial, which I'm going to break down into its factors. It's x plus 2 times x minus 1. This one here is an x minus 1, x plus 1. And this one over here, I'm going to start out by factoring out a 2, and it's going to leave me with x squared plus 3x plus 2, which then tells me that my factors are 2, and then this is x plus 2 and x plus 1. So let me kind of clean this up. 2 times x plus 2 and x plus 1. So when I'm looking for my least common denominator, right, I got to look at all these factors. Every single one of these factors has to be represented in my least common denominator. So it's going to be 2, which is this one. It's going to be an x plus 2, which takes care of these. It's going to be an x minus 1, which takes care of these, and then an x plus 1. So there's a lot of factors here, but notice I'm going through and I'm checking them all off. So just take your time. You go to the first one, you have a 3 in the numerator spot, and when you multiply by the least common denominator, the x plus 2 is going to cancel out, and the x minus 1 is going to cancel out, which means you're going to multiply the 3 by 2 and by x plus 1, because those weren't included there. So then you go to the next one, minus 1. What are you going to multiply that one by? Well, again, I'm going to take out an x minus 1, and an x plus 1 is going to get canceled, leaving me with a 2 and an x plus 2. And then it equals 7 times something, right? So again, I go back through and I say, okay, the 2's going to cancel out, the x plus 2 is going to cancel out, and the x plus 1 is going to cancel out, leaving me with just x minus 1. And so now that I've canceled out, done all my canceling, and I see that I have no denominators left, now it's a matter of just mathematically taking my time and doing this a little slow. So I'm going to do 3 times 2, and then I'm going to distribute that 6. So I'm going to get 6x plus 6. Then it's, this is going to be minus 2 here, and then I'm going to distribute that. So minus 2x minus 4 equals, and then I'm going to distribute 7x minus 7. So on the left, I'll combine my like terms. On the right, I don't have any like terms to combine, so now I'm able to kind of adjust my equation. So I'm going to subtract 7x from both sides. I'm going to get negative 3x plus 2 equals negative 7. I'm going to subtract 2 from both sides, and I'm going to get here negative 3x equals negative 9, and I'm going to divide both sides by negative 3, and I'm going to get that x is 3. And again, now I just have to see, is it extraneous or not? And notice none of my denominators will be 0 if x is 3, so I'm okay. My denominators can't be negative 2, or they can't be negative 2, they can't be positive 1, they can't be negative 1, but 3 is not a problem, so it's a valid solution. So we keep going. Again, take your time, nice and slow, right? So the first thing I'm going to do is factor this one. I'm going to factor out the GCF of x, and it's going to leave me with x plus 1. So I know that my least common denominator here is x times x plus 1. When I multiply the first one, 4x plus 3, by x times x plus 1, I know the x plus 1 is going to cancel out, leaving me with x. When I do the 2 over x, I know the x is going to cancel, leaving me with 2 times x plus 1. And when I multiply this one over here, both of the terms cancel out, leaving me with just 1. So again, now it's time to distribute here. 4x squared plus 3x, and then I get plus 2x plus 2 equals 1. Now here again, let me simplify the side real quick, but notice as soon as I saw that x squared, I kind of cringed because I knew it's going to be a quadratic. So minus 1, since it's a quadratic, I have to get everything on the same side and set it equal to 0. And then I have to work on factoring it. Again, a is 4, so it's not as simple. What numbers multiply to 4 and add up to 5? Well, that's going to be 4 and 1. And so again, I expand it to 4 terms. 4x plus 1x plus 1 equals 0. GCF of the first term, GCF of the second term, or second group, and then I get my first factor is going to be my GCF of these two, which is x plus 1, and then the other is going to be 4x plus 1 equals 0. And again, this means then that x equals -1. That's one solution. This one will take a little bit. 4x equals -1 and x equals -1/4. So I have these two answers here. Again, I have to look and see, are any of these extraneous? And I realize that if x is -1, this denominator here would be 0. So x cannot be -1. So this is the only solution to this problem. Last problem we're going to do here is this one. So again here, now notice here I have 2x minus 3 times 2x minus 3. And here it's just 2x minus 3. So what you might think to do here is you might think, and so if I just pick 2x minus 3 one time, because notice it shows up twice in the second fraction. Since it shows up twice in the second fraction, it has to show up twice in my LCD, because think about it, when I multiply this term by just 2x minus 3, only one of them is going to cancel, and it's going to leave this other one still in the denominator. And so you basically take the common factors, of course, at the bottom, but to the highest amount that they show up in a single fraction. So if it shows up 2 times in a single fraction, then you have to multiply it by 2x minus 3 2 times, okay? So what's going to happen is your first term, 6, is going to be multiplied by 2x minus 3 and 2x minus 3. Your second term, the 7, is you're going to cancel one of the 2x minus 3's, but you're going to have one left over. And then the last one, both are going to cancel, leaving you with just the 3 at the top. Okay, so you have to be careful there when you have a term squared. All right, so now we've got to kind of expand all this out. It's a lot of work. I'm going to first, first I'll distribute. Actually, no, I think I'm going to FOIL first. So I'm going to FOIL this perfect square trinomial, really. So it's going to be 6 times, and I'm going to get 4x squared minus 12x plus 9. Over here, I'm going to distribute the 7, 14x minus 21 plus 3. Now I'll distribute the 6. So I'm going to get 24x squared minus 72x plus 54 equals 14x minus 18. So at this point, I'm going to, I see that x squared there. I can't avoid it. I know it's a quadratic. So I'm going to have to subtract 14x and add 18. So minus 14x plus 18. This will make the right side equal to 0, and the left side will be 24x squared minus 86x plus 72. So I would love to say that this is, I can divide everything by 24, but I can't. So the best I could do is divide out a 2, which again is better than nothing, because anything's better than these huge numbers. So 12x squared minus 43x plus 36 equals 0. Again, it's still not going to be easy. I still have to factor or find something that's going to multiply to 432. And is going to add up to negative 43. So I have to start thinking of my factors here. And so these factors are minus 16 and minus 27. So I'm going to do 12x squared minus 16x minus 27x plus 36 is 0. GCF of the first two, 4x. That's 3x minus 4. GCF of the second two, minus 9, which leaves me with 3x minus 4 equals 0. Again, 3x minus 4 is the GCF, and then here I get 4x minus 9 equals 0. So again, I set it now equal to 0. So 3x equals 4, and x equals 4/3. And then here, 4x minus 9 is 0, 4x equals 9, and x equals 9/4. So I basically have two solutions here. I do have to make sure that those solutions do not make my denominators equal to 0. So I would have to come back and check here. 2 times 4/3 minus 3 does not equal 0. 2/3 would make it equal to 0, so that's not it. Same with the other side. So both of those are fine, valid solutions, but a lot of work for sure. So now we get to these absolute value equations. And again, we've learned about absolute values before. You learned about them in Algebra 1. Hopefully you remember it. If not, I don't think it'll take you too long. But again, just know that you do have to check for extraneous solutions in here as well. Okay, so your solutions must be checked. Absolute values can never equal a negative number, so we'll talk about that. Again, we do have to check the solutions. So let's come over here to some basic problems, okay? So first of all, remember that an absolute value is a distance of a value from 0. So again, if I have, the absolute value of x equals 10, we're like, okay, what numbers are 10 units away from 0? What values of x would represent 10 units away from 0? And we realize that there's 2. We know that negative 10, okay, is 10 units away from 0, and we know that positive 10 is 10 units away from 0. So really, absolute values always end up being even, right? But the x value in here can either be negative 10, because the absolute value of negative 10 is 10, and the absolute value of positive 10 is 10. So when we're solving for absolute value equations, we have to consider always that whatever is inside of, once it's isolated, first of all, once all you have on the side is the absolute value, we know that whatever is in here can equal the positive or negative value of what's out there. So in other words, we know that 2x plus 1 can either equal negative 5 because the absolute value of negative 5 is 5, or it can also equal positive 5 because the absolute value of positive 5 is 5 as well. So how we kind of set it up, because we're trying to find what x value is going to make the inside either negative 5 or positive 5, is we isolate the absolute value, and whatever's in here, we turn it into two equations. And we say, okay, 2x plus 1 can either equal positive 5, and 2x plus 1 can equal negative 5. Either one of those, whatever x value makes it equal to 5 or negative 5, is going to be valid in this equation. So we just solve each one. So 2x equals 4, so x equals 2. And then we come here and we do 2x equals negative 6, so x equals negative 3. Now, once you find your solutions, you should obviously check them and make sure they work. So if x is 2, you're like, okay, 2 times 2 is 4, 4 plus 1 is 5, and so it equals that. Perfect. And we do the negative 3, and we get negative 6 plus 1, that's negative 5, and the absolute value of negative 5 is 5, and so it's perfect, okay? We go to the next one, and we see here again the absolute value bars are isolated. Everything else is on the other side as it should be, and so we're like, okay, whatever's in here, okay, has to equal negative 5. Well, wait, right? Does the absolute value of anything ever equal negative 5? No. So once everything is isolated and all you have is the bars, if what's over here is negative, then this is a no solution, because there isn't an absolute value. There's an absolute value of, if this was negative 5, it would equal positive 5. If this was positive 5, the absolute value would be plus 5. It's never going to be negative 5, okay? So this one's a no solution. We're going to get to some more difficult ones here. So again, notice that your absolute value bar is isolated on the left side, as it should be, okay? So once it's isolated over here by itself, we know that we can set it up as two equations, and it's going to be x squared minus 3x equals exactly what's here, minus 4x plus 6, and x squared minus 3x equals the opposite of whatever's there, or the negative of it, okay? And so kind of think of it as is, and then the negative of it. So over here, when I'm solving this left one, I'm just going to start combining my terms, notice it's an x squared. I'm going to have to solve this quadratic. So I'm going to have to add 4x and subtract 6 from both sides. So again, plus 4x minus 6. So here I've got x squared plus x minus 6 equals 0. Factor, that's x plus 3, x minus 2 equals 0, which means that x equals negative 3 and x equals 2. And again, I have to check for extraneous. But before I do that, I'm going to solve the right side, right? The other equation. So far I've got two things I have to check here. When I come over here to the right, I'm going to have to do x squared minus 3x equals positive 4x and minus 6. And again, it's a quadratic, so I'll subtract 4x from the left minus 3x, and I will add a 6 to the left. So that'll cancel them from there. Again, combine my like terms. All equals 0, and I get x minus 6 times x minus 1 is 0, so x is 6 and x is 1. And so again, two more. So there's 4 numbers here to check. Now, I'm not going to check them all online. I'm going to do one, and then I'll just do the rest off camera because I don't want to take all the time on checking. You need to check all of your solutions every time. But I'm going to start with, I know that negative 2 doesn't work, I think. So I'm going to start with that one, right? So I'm going to come over here and I'm going to try 2, not negative 2, positive 2 rather. I'm going to check this one. So I'm going to plug in 2, so that's 4 minus 6 equals negative 2, and the absolute value of negative 2 is 2. On the right side, negative 4 times 2 plus 6 is negative 8 plus 6, which equals negative 2. Notice these are not equal to each other, and so this is extraneous, okay? Now, I checked on negative 3, and it did work. On the other side, I'm going to check those two. And on the right side, the positive 6 does not work. Okay, it does not give me the right answer. And so there were 2 extraneous here, and there were 2 valid solutions. So negative 3 and positive 1 both worked. In the other case, and then the other 2 were extraneous. So you need to check them all. I'm not going to check them all. I'll let you know which ones don't work, and then you can make sure your work matches it, okay? Again, we come over to this problem here. We're going to start working it out. And again, the square root, or the absolute value, is isolated, so we're going to do x squared plus 4x equals 7x plus 18. And at the same time, we know that x squared plus 4x is going to equal the opposite of 7x plus 18. So on the left side, I'm going to move everything over. So I've got plus 4x. I'm going to subtract 7x, and I'm going to subtract 18. I'm going to get x squared minus 3x minus 18 is 0. It factors to x minus 6, x plus 3 equals 0. So x is 6, and x is negative 3. 2 things to check. I go to the right side, x squared plus 4x, distribute the negative, so minus 7x, or wait a minute, equals, x squared plus 4x equals negative 7x minus 18. And again, I know I have to bring it over. So I've got x squared plus 4x plus 7x plus 18 equals 0. X squared plus 11x plus 18 is 0. I've got x plus 9, x plus 2 is 0. So x is negative 9 and x is negative 2. So there's a lot here to check, right? I've got 4 things to check. I'm going to check them off camera, and I'll let you know which ones work. And so in these, when I check them, negative 3 and negative 9 did not work. And the only ones that worked were x is 6 and x is negative 2. Okay, so again, you have to check it yourself. Each time, every solution you get, you have to check and cancel out any ones that do not work.